So I want to tell you a little bit about interval notation. There is a chart that's in the section 2.4 in the workbook. It's in various pages depending on what course you're in and what book you have. But it's also in section 2.4 in the e-text on page 78. And it's not something that you work with directly, but it's just there on the page. I want to explain a few things from that because I know some people have difficulty with it. So the first part of the chart that you saw on the screen just now has single inequalities, like x is greater than or equal to -4, for instance. And that inequality is often written in set builder notation like this: x such that x is greater than or equal to -4. But there's other ways to do that, and the easiest way to write it down for mathematicians is a shorter form called interval notation. We want to make sure that you understand how to make that interval notation. The best way to get to interval notation is to always, and I mean always, graph it. So we're going to draw a graph of this first. And graph of it is just a number line. We'll locate 0 on it and put some numbers on it in various places so we know where we are. Make this a little longer here and put 2 up here. So I got every other number there, all the even numbers on there. And this says greater than or equal to -4. When we're graphing this in this textbook, you may have seen open circles and closed circles in other textbooks, but we'll use, for greater than or equal to or less than or equal to, we'll use a bracket. Less than or equal to will have a right-hand bracket. Greater than or equal to will have a left-hand bracket. If it's just less than or greater than, we're going to use parentheses in the same manner. Okay? So this says greater than or equal to. Greater than or equal to uses a left-hand bracket. -4. That means we're going to put it right here on -4. And that means that we can include x is equal to -4. The bracket includes -4 in the graph. The parenthesis does not. It just starts after that. And that graph would be shading the line above -4 and the arrow to say it keeps on going. Okay? Now that we have the graph, we can see how far to the left and how far to the right the possible values that fit this inequality are. And that translates to this interval notation. We're going to use that same bracket for the -4 end. That's as far to the left as it goes. How far to the right does it go? It goes to positive infinity. So we'll put an infinity sign here and always parentheses on infinity. Never a bracket here. So that's a simple one. There's several other examples in that chart on page 78 that we showed you. Let's do a couple of more complicated ones. You may see interval notation like this. X such that -2 is less than x, which is less than or equal to 3.1. Okay, that's called a compound inequality. And this x is both, we can interpret it as greater than -2 and x is less than or equal to 3.1. Okay? If we graph that, we have a number line like that, greater than -2, or -2 being less than x here, means the lowest it goes is negative 2. So we're going to put a parenthesis there. Again, we use parenthesis because this said less than or greater than. So it starts at negative 2 and comes up to 3.1. Now, this is going to get a bracket because that's less than or equal to. And it's going to be slightly above 3. And when we put a symbol, an end point symbol like this on the graph, and it's not on that number itself, make sure to label it with the number it does end up at. Okay? And this interval would include all of the numbers in between. So it's trapped in between negative 2, positive 3.1. And now we can easily write the interval notation as using the same endpoint symbols and put negative 2 on the left and positive 3.1 on the right.